Okay, let's look at this example here. Now notice that we've got two equations with two unknowns. Okay, but you may also notice that this equation is just a multiple of this equation. Or another, you could also look at it as this equation here is a multiple of this one. You could just multiply this by a half and you get that equation. So right away, you may notice that these are essentially representing the same equation. So there's really only one distinct equation here, but we've got two unknowns. So, but let's look at this and see how this goes. Because in the essence, when we have a situation where we have more unknowns than equations in our system, we're going to run into a situation where we're going to have an infinite number of solutions. So let's just go through it so we can see why that is. Okay. So again, if I do my eliminate a row operation here and I do a multiple of this one, get rid of this one. So I'm going to multiply by -2. So row 1, -2 times row 1 plus row 2. And so what's that's going to happen is, well, this is going to be the same. Okay. And then what happens here? I get 0 equals 0. Now before, remember, 0 equals 0 means that, hey, there was redundancy, which we already knew, right, from what I just said. Now, what does this mean in this case? In the last case, there was redundancy, but in the end, what happened? We ended up with two equations with two unknowns, and we were able to solve for a specific solution. But in this case here, what happened? It reduces to one equation with two unknowns, which is going to end up having an infinite number of solutions in this case. So what does this mean in this situation? It means that one of the variables is going to be free, meaning that we can make y be whatever we want it to be. But once we decide what y is, it will determine x. And so in this case, y is free to be whatever it wants. Okay? But once we determine y, once we pick a value for y, then x will be determined. In this case, we have an infinite number of solutions. Okay? So in this case, it's going to be all real numbers, okay, for x and y. Okay, and that's it. Okay, yeah, we'll do another one.